Okay, so that was a little bonus there. We've seen that we can do pattern matching in list comprehensions as well. And things don't go wrong. It just actually works like a guard. Only take the things which match the pattern and ignore everything else. Okay? All right. So in the last part of today's lecture, I want to talk talk a little bit about working with lists of lists and mention a few standard functions that turn out to be pretty useful. And along the way, maybe we'll look at a slightly longer example, or maybe I'll make a short video of that. I was going to look at the example of representing a noughts and crosses tre i rad game. So let's start by talking about lists of lists. So there are some special cases of lists, and that's when we're working with lists of strings, lists of characters. Okay, so lists of strings are lists of lists. So here's a list of lists. So there are some standard functions. One of them is, for example, unwords. This is a list of words, and we're going to join them all together into one word. So we're going to unword them. One way to refer to the thing that I typed on the previous line is to type it. That refers to this thing here. Saves me a bit of typing. If I unword that thing, it will take this list of lists and turn it into one list, putting a space in between each one. So it's treating this as a list of words and joining them all together into one long word. And when you join words together, in English at least, you put a space in between them. That doesn't work so well in Swedish. There's also a companion function, which is just called words. And if we do words on, it splits the list of characters into a list of lists of characters where it ignores it breaks them at every space. And you notice the space has disappeared from that. If we put two spaces in, it doesn't make any difference. It will ignore all the spaces between the words. And there's another function called lines and unlines, and they do very similar things, except what they're looking for is a special new line character, a thing that when you print it out causes it to break onto the next row. And they're all very useful utilities. I'm not going to look at the definitions, they're not so interesting. Another example that we've seen, very briefly, is the concat function. Concat takes a list of lists and squishes them all together into one list. You'll notice that that's not the same as the unwords function. For one reason is that it doesn't put a space in between the words, but another reason is it has a much more general type. Unwords function takes a list of strings and gives you a string, whereas the concat function takes, oh my goodness, it takes a thing containing lists and converts them into a single list. And that thing can be anything which is called foldable, which is in the foldable gang, which includes lists. We're not going to really look too much at this foldable gang in this course, but what you need to know at least is that concat will work on lists of any type as long as all the lists have the same type, and we'll join all those lists together into one list. Okay. Any questions? Okay, in the last 12 minutes, I want to take one example which combines lists of lists and modeling using data types. So many situations we want to model a table or a grid of some sort. And one fairly simple way of doing that, not always the most efficient way, but one at least very simple way, is to model a grid as a list of lists, where each list inside the big list corresponds to a row in the grid. So the first list will be the first row, the second list will be the second row. So let's take the example of representing the noughts and crosses game, where the board can be any size. So we're not going to worry that it's 3 by 3, which is the usual one you draw on a scrap of paper, but let's say it can be any size. So I'm going to call it a grid, and I'm going to make a new data type for it, for various reasons. So how many different types of grid are there? Well, there's one for each size, but we're going to kind of ignore that. We're going to say that a grid is just the constructor grid applied to a list of lists of marks. And a mark is going to be one of three things. I'm going to use the British version here, noughts and crosses. It's either a nought, a cross, or it's blank. Another way to represent this would be to say that it's a maybe and then either a nought or a cross. But I'm going to do it this way. I maybe should have done it with a maybe, never mind. Okay. So let's see how you might represent a board using this notation. I haven't derived show yet, but I'm going to do that for a reason. So here's an example. Here's how we'd represent a board with where the top row is a nought and a blank, then a nought. The middle row is a blank, nought, cross, and the bottom row is a cross, cross, nought. So I've written them over 3 lines, so it's easy to sort of see what I mean by the board. But of course, the fact that I've written it over 3 lines doesn't mean anything. It's just to make it easier to understand the example. So let's uncomment that. I think I've got it. So any questions about that? Okay, now if I want to print one of these things out, it's maybe not so nice to represent it using this notation. If I do deriving show for this guy and this guy, I can do it quickly. That means, what does that mean? Well, it means now at least if I reload this, I can at least print out the example grid, and that's what it looks like. It's not very readable. If I want it to print out in a more readable way, in a way which looks more like the representation we have in mind, what I need to do is not derive show, but actually define my own version of show. So instead of deriving show, what I'm going to do is I'm going to say, yes, I want this data type to be in the show class, but I'm going to tell you what the show function should do. Okay? Put it in the show class using my show function. How do we do that? What we say, we give an instance declaration. We say instance show. We're going to create a new member of the show gang. Who's it going to be? It's going to be Mark. What do you need to be in the show gang? You need a show function. Let's define the show function. So how do we show nought? Well, we're going to show that with an O. How do we show a cross. Well, we're going to show that with an X symbol. And how do we show a blank? Well, we'll just use the empty string. So remember, show has to be a function from a thing to a string. So what I've done, instead of deriving show and saying to Haskell, you work out a show function, which will give me this kind of stuff, I'm saying, I'm going to derive the show function, but I want this guy still to be in the show gang. Here's the show function. So I need a where clause, and I need an indented definition of the show function. So these two spaces in the beginning are important because they belong to this instance declaration. Okay? Show. Yeah, shoe blank. Blank shoe. So now if I print out, not word, please, nothing but word. If I print out that example again, now instead of printing naught blank naught, it will print out the new representation that I've just told it to print out, which is these O's and these crosses and blanks. But I'm still not quite there, because I want to do this one as well. How many minutes have I got left? 6 minutes left, that's plenty of time. So let's try and define a show function for this guy. I should have probably thought about this in advance. Instance show grid, where the show function that I want to define for this guy, if you give me a grid and a lists of marks, so we know that this is a list of marks. What is it going to be? How am I going to do this? Well, let me just define a function for showing a row. I'm going to define a function inside this function. I'm going to find a helper function for showing a row. A row is a list of marks. I'm going to do it with a list comprehension. I'm going to take every mark, M, from the list of marks. A row is a list of marks. And I'm going to show each one of those using the function that I have down here, because that's the only one that has the right type. And then I'm going to join all those together with what function? Suggestion? Yeah. You could use concat. Maybe it'd be nice to have a space in between. Do you remember a function that puts a space in between strings? Unwords. That's the one, unwords. So I'm going to use unwords of that. So that's showing one row. Okay? That's great. But so now let's do the whole thing, and I'm going to do something similar. I'm going to build a list comprehension where I take the rows from the list of rows, one at a time, and for each one of those rows, I'm going to use the show row function on that row. Now I've got a list of strings, and I want to convert it into one big string for printing out on the screen. But the string that I want to convert it to, it should, after every row, it should start on a new line. So there's a new line character which you can use to put something on a new line when it displays it. But we can use another function a bit like unwords, which will do that for us. It's called unlines. It will put each bit of the string on a new line. In other words, it'll join all the strings together, but with a new line character, special character called the new line character in between. Will this compile? It compiles, yay. Let's try the example grid. What does it look like? Awesome. It shows us now the grid with each row on a separate line. And the reason why it looks nice like this is because there's a new line character, which you can't see. It's invisible. It's caused it to start printing the next line down here. Okay. Okay, that was a very useful little introduction to stuff that we will see again on Monday. Because on Monday, what we're going to do is to see how to tell Quick Check how to generate random stuff. And there's a special type class for that, and we're going to use this same idea. That's all for today. Thank you.